So you probably know deep neural networks have been revolutionizing lots of areas, like speech, natural language processing, computer vision. So we've been using deep neural networks since 2013. It was popular since 2012 for computer vision, right? So since then, we've learned a lot how to use them for our problems. So the goal of this talk, at the end of this talk, I'm hoping that you would get 3 things. First one, how does data for commerce look like, right? So I'm going to give you a very high-level view and slowly dig deeper and deeper. The second one is, what are the top problems that we are working on to solve our customer problems to give them better experience? The third section, I'll take a deeper dive into what the model actually sees when you show an image to it, right? So for example, brand prediction, as Lars pointed out. So let's get started. If you're a data scientist, you probably start with the data first to get your hands dirty, understanding the data, get some insights, and then see how to solve the problem, right? So I'm going to start with the data. So first, at very high level, just want to give you very high-level statistics about eBay data. These numbers are from Q2, because Q3 numbers were released just yesterday. At any given time, we have over 1.3 billion items. The latest number is 1.4. 90% of them are fixed price, meaning 10% are auctions. 80% of them are new items. And these items are sold by so many different sellers. So what that means is if you have a given product, let's say a microphone, the same product could be sold by hundreds or thousands of different sellers. So there'll be, for example, uploading different kinds of pictures from different angles, different illuminations, different kinds of backgrounds, right? So we have a lot of diversity of data because of that. And also, if you look at the velocity of different products that are being sold, entering our ecosystem and leaving our ecosystem, it's pretty fast. Like, for example, every 5 seconds, a watch or a smartphone is sold. And depending on the geography, we get different kinds of inventory being moved around. At a high level, we can classify the data into 4 different buckets. There are more buckets. I'm just going to talk about one bucket in detail, but here are 4 major ones. When an item is being listed, right, the seller actually augments with a lot of different information, like images, title, price, and so on. I'm going to talk more details about item specific in the following few slides. We have so many different buyers. So when they enter our ecosystem, we learn more about them, right? How often do they buy? What kind of things that they like, and so on. Same for sellers. How frequently do they sell? Are they first-time sellers? Are they professional sellers, right? What kind of feedback they get from the different users? Whenever somebody's using eBay, they're clicking on different things, so their journey is being captured, right? Maybe I searched for a specific shoe, and I clicked on certain items. So this kind of data is also logged. So session data can also be used to train our models. So I'm going to dig deeper into what we call the item-specific information. In this case, this is what we call as view item page on eBay, right? When you click on an item, this is what you see. So in this specific example, I'm going to talk about different things that are on this page, because when you train a model, deep neural network model, you actually feed the data, right? There are different kinds of data here. So I'll highlight a few things. There's a main image. And there are multiple images that you see in the thumbnail. So each listing will have multiple images. And you see title at the top, price, some information about the seller, and some similar items at the bottom, and even more. What this means is, if you feed lots of images and title together to this neural network, you can actually ask it train how to predict the title, right? From image to title, or from image to price, from image to other things, right? Each item also has things like these name-value pairs. These are items like brand, color, style, and so on, right? So when you have this information, you can also train the neural network to predict brand. You can teach it to predict, what type of pattern the dress has, and so on, right? And we also have more detailed things like a description. This item in particular has a very short description. So just the view item page itself has very rich information, right? And we have so many view item pages. So these are some of the data labels that I'll be talking about in this presentation related to images. So every single item has something called category information. This category information actually is organized in the form of a tree. When I say leaf category, I mean things like athletic shoes, boots, chair, table, cell phone, and so on, right? So every single item has this label. Also, these items have labels like brand, style, and so on, like I mentioned before. So these are what I'll be referring to as visual aspects or attributes. The top one is a leaf category. So throughout the slides, I may be referring to leaf category and aspects. So this is what I mean, right? So these are the labels we have available, let's say, and we have lots of images. Now, how do these images look like, right, for eBay? In this case, I'm showing a visualization of various handbags sold on eBay. Almost 50% of these images have some kind of a complex background. They don't just have white background. This is a strength for us because when you have diversity in the data, we can actually train our models to learn the diversity, right? If you have only white background images, it's very hard to train the system to work in the real world, because in the real world, not everything has white background. Things occur in the context, right? So only 5% of the images, roughly 5% of the images have white background, right? These are like, you can call them as stock quality images, right? So that's how the data looks like if you see from, let's say, a 5,000 feet view. Right. Now, if you dig deeper, I talked about image quality. Image quality can mean different things. So you may use the camera angle to use as a factor for image quality. You can look at illumination. You can look at the background clutter, how focused the object is, and so on. Right. So in this case, for this Louis Vuitton bag, on the left side, you see lots of stock quality images. On the right side, you have other images that are appearing in context, right? So in this case, many people would think that the pictures on the left have a high quality. But what about if you have a picture like this, right? These are real listings on eBay, right? On the left side, you see dress that's hanging in the outdoors. On the right side, you see a chair in the outdoor scene. Even though the right side image doesn't have a white background, we would consider that as a high quality image. So we have all kinds of varieties at eBay. And also, if you look at a specific product, right, like in this case, it's a red Puma shoe, right? As a human, we think that, OK, they look kind of similar. But for a machine, they look very different, right? These are pictures taken from different angles, top view, side view, and so on, right? So this is a kind of challenge that we have. Given a single image, how can we understand that image well and make some predictions, right? So until now, what I did was I gave a very high-level view of eBay data, right? High-level statistics, the velocity. I talked about 4 different buckets: item, buyer, seller, session. Those are different kinds of buckets. And now I double-clicked on the item-specific information, things like title, images, and so on, and talked about leaf category and different aspects. And I also talked a little bit about how images look like on eBay, right? Now I'm going to move on to some of the top computer vision problems that we look at for e-commerce. When somebody takes a picture, there are multiple objects, right? So first thing we want to do is, where are these objects, right? So in this case, you can see there's a bed, there's a chair, there's a shelf, and so on, right? So that's the first step. So this, I like to simplify this as where, right? The next one is once you locate where the objects are, we want to know what they are, right? So this is a recognition problem. The first one is what we call localization or detection problem. This one is a recognition problem. So here, if you locate the chair, we want to know what type of chair it is. And now once we know what that object is, users typically want to see more objects that look similar to that particular chair or chairs sold by different sellers, right? So we need to match this object against our inventory. So that's the next one, which is find. So I talked about three big things in this flow. First one is locate where the objects are. Next one is what these objects are, and then find these objects against the eBay inventory, right? So here is one example where a seller is trying to list a product. They take in the picture. Typically they need to type the title, right, and then fill in some forms like this. Hey, what is the category they want to list it under? What is the brand? What is the color? And so on. Oftentimes, sellers don't fill all this information, right? So in the background, after they upload the pictures, we actually make predictions using the image and other information. In this case, these are the predictions on the right from our computer vision model. So here is a use case where we actually populate the missing information using computer vision. And this model was actually trained using the labels that I showed earlier, leaf categories and the aspects, right? So this just wanted to show an example of this. I would like to acknowledge Hadi Kapoor, who did most of the work that I'm going to present from now on, specifically the brand prediction. More details on this specific work was published in this paper last year at ECCU workshop. I encourage you to take a look at that. It's on archive. Okay, so now we talked about data. I talked about the high-level computer vision problems that we look at, eBay. And now, this is a very simplified version of what we do. We have a single neural network in the middle. When an image comes in, we try to predict multiple things. So when we train the neural network, we also give all of these labels, like categories, what are the brands, what is the color, what is the style, and so on. And thus, the neural network knows how to predict these labels given an image. Also, I talked about find, right? Once we know, what the object is, meaning categories and all these aspects, we want to match against the eBay inventory. We want to do this very fast. So what we do is we extract compact signatures. These signatures are predicted by the neural network as well, the compact binary signatures. And here are some examples of the predictions. And you can see these are not very obvious for the human, right? In this case, these are different brands from fashion, like North Face, Levi's, Louis Vuitton, and so on. Here's an example of brands from health and beauty. The previous one was fashion. You can see, I don't even know some of these brands, but the machine is able to recognize all of these brands using a single model. Here are different brands for smartphone, more home and garden. And here are different things just from fashion, right? Going beyond brand. We can predict things like neckline, what is a pattern, things like floral stripes and so on, in addition to brand, right? Occasion is a little bit abstract, right? And we can also do things like this, like counting. How many handles does the faucet have? What is the denomination of the dollar bill and so on. So again, I'd like to summarize. First, we talked about the data and talked about high-level problems at eBay. I talked about just I showed the very simplified neural network, trying to predict category aspects and so on. We use models like residual network 50 with 50 layers and so on, right? And also we are starting to look at neural architecture search. So I didn't talk details of the neural network model itself. So now, imagine the human brain. Nobody understands the human brain completely, right? But we know some things about the human brain. How did we learn? So there are these equipment techniques like functional MRI, right? We go into this MRI machine. Maybe the human is shown certain images, a certain kind of stimulus, and we measure to take some measurements. And there are some visualizations, like you can actually show which part of the brains are lighting up. Red means high activity, blue means low activity, and so on, right? So we're going to do similar thing with the neural network. Again, nobody completely understands how neural networks actually make these predictions. There are some ideas, right? This is an evolving work. So I'm going to take this particular use case where we try to predict a brand given a single image, right? I'm going to skip that because I'll come to that later on. So when somebody tells you about a brand, right? Let's say Nike or Canon, Nikon, what comes to your mind, right? Oftentimes what comes to your mind is a logo, right? But brand actually goes beyond logo. It's not just about the logo. In this case, if you know about sneakers, you probably say immediately that this is an Adidas NMD shoe. But why? There is no Adidas logo here, right? There are actually some subtle triangles here and there. It's hard to see on the screen. The two rectangle things, the blue and red rectangles you see at the bottom, that's what makes it an Adidas NMD shoe. That's like the signature that they use. It's not about the logo, right? Similarly, this is an Air Jordan 11 shoe. How do you know it's that, right? So you can also see there's a red sole at the bottom. It's supposed to be the leopard paw print, right, if you actually look at the bottom of the shoe. And there are other attributes, right? You don't see an Air Jordan logo here anywhere. Here is an example of Nike Air Max. How do we know it's a Nike Air Max? There's actually a subtle Nike logo. It's hard to see, black on black. At the bottom, you see these air bubbles. I think the circular things. It's a 5, that's Air Max, instead of 4. Right. So, and this is a Christian Louboutin, right? The red sole, lipstick color sole at the bottom. So the point I'm trying to get at is the machine is able to make these predictions even though there is no logo. So, but the machine, since it's learning from a lot of data, it actually learns all these subtle things about different objects without us actually pointing that to the machine. It just learns on its own magically, right? So, for example, it's very hard for a human to predict these brands. Maybe somebody would, but not many people would be able to predict these brands, except possibly the bottom right, the Chanel, because the text kind of shows up, right? But the machine, actually, the model that we have actually predicts them with a higher accuracy. So now, as I mentioned earlier, this is a problem we have, right? Given an image, we pass it through our neural network, makes a prediction. In this case, it predicts a brand. Similar to the fMRI machine, right? We show an image to the human brain, and these fMRI machines measure this brain activity, and you can visualize them as heat maps. We're going to do a very similar thing here. Okay? This actually falls under this evolving field called explainable AI, used as XAI in short. Right? If you search the internet, you'll see lots of articles about that. The concern here is, okay, these deep neural networks are so complicated, nobody understands in detail how these deep neural networks are making these predictions, but we use these deep neural networks to make some decisions for us, right? So we need to understand what kind of biases these models have, right? So that's why these kinds of techniques that I'm going to talk about, right, are important. These are what we call model interpretability, right? So I like this quote from Richard Feynman. I learned very early the difference between knowing the name of something, in this case Nike or whatnot, and knowing something, right? So in this case, when we pass this image to our model, it actually, using some technique we use is a little bit older technique, excitation back prop. You can look it up if you want to know details. It's not from our group. If you see a red hotspot, that means the neurons in the neural network are actually firing in those regions, right? So in this case, it's firing on the logo, right? It's predicting Nike because of the logo. It's also because it's looking at the sole, at the bottom. It's an athletic shoe, right? Nike athletic shoes are very popular. In this case, we actually had the label Disney. We never had the label called Tiger or anything like that, right? We passed lots of examples of Disney, images labeled as Disney, right? And in this case, it's predicted accurately as Disney. And you can see that the neurons are actually focusing on the tiger character here. Same in this case, Adidas, it's focusing on the stripes, right? Vera Bradley, if you know, teenagers love this, heavy patterns, right? Louis Vuitton, similar thing, repeating patterns. The iPhone, the home button is signature, right? Ignore the 4 hotspots in the corner. That's an artifact of the model, and so on, right? So this is what we can do it for go beyond brand, right? Like stripes, colors, and so on. So just looking at all of those on one slide, you'll notice something. These red spots sometimes occur in a very small localized region, very small region. Sometimes it's kind of spread out. If you look at the Vera Bradley, it's more spread out than, let's say, the Nike in the top left, the logo, right? It's a very, very narrow region. So what we want to do is we want to think beyond logos to understand how these machines make the predictions, and we want to look at the neuron level also. So we actually look at the strength of these signals that we get from these neurons, right? High strength means the red signal that you saw, and the extent, how big of a region are these neurons firing on, right? Just by looking at these, we can go beyond the single point called brand logo, right, for brand prediction. And now we use a data set that contains more than 1,200 brands and close to 4 million images, and it's only handbags for now. To simplify, here are just some examples. You'll see repeated logos. You'll see big images, like in the first row, some kind of a pattern. In the bottom row, you'll see like a very focused logo, right? And now almost half of this data set have some kind of an obvious logo, and half of them didn't have any logo, right? Sometimes, most of the time, logos are appearing as a singleton. Other times, it's repeating, right? And these are some examples where the neurons had a very high strength, and you can see a very clear logo. And these are some examples where it was over a larger region, like repeated logos or large pictures as in the first column. Right? And we can actually put it in a plot. Instead of a single point, which is a high strength, small extent, which is like a typical logo, right? We actually give a whole spectrum here based on strength and extent. Right? And we also looked at clusters of neurons. And you can see there in the first row, there are some neurons that understand only Harley-Davidson, right? And you can see Harley-Davidson actually occurs in different forms here in the first row. Still, it's able to recognize Harley-Davidson. And there are some cases, like in the bottom row, you see this hobo-style bag, like a U kind of a shape. I think it's recognizing that shape. So these bags from Cole Haan and Ariani have that kind of a shape. So we think it's learning those things, right? And we didn't ask these neurons to look at these specific features. They just learned on their own. And it's important for us to understand what kind of biases they have. We can even give names to these neurons to see how they fire if we give a different brand image, right? So just to summarize the last part, right? The applications of this kind of interpretability is, there's a new field that's forming called explainable AI, XAI, right? So what kind of biases do these models have? If they have bias, how can we correct the bias, right? Can we sample the data differently to correct the bias? Can we use a different kind of a network topology or whatnot, right? And then we can improve the models in this spiral life cycle, just like the previous keynote speaker talked about. So start with the data, right? Do diverse sampling, stratified sampling across different dimensions, different kinds of sellers, different kinds of image quality, different brands, different price range, and so on. And now train the model, ablation study, hyperparameters, and so on, evaluate, right? And then push it to the system. And then now, when it's in the field, we get lots of feedback based on the interaction from the user, whether they like the model, whether they don't like the model, when we make the mistake, when we do very well. And now this goes back to the new data that we're going to collect. And that goes back to the model training. And that's a system that we have, the life cycle. And I would like to summarize the whole thing quickly. So you have 3 takeaways, right? I talked about the data, talked about high-level statistics, the velocity, right? And then about 4 different buckets: items, buyer, seller, session. And within the items, I talked about different labels, categories, aspects. Talked about high-level problems. Where are the objects? What is that object? And then find that object with the inventory. And then talked about brand prediction. Brand is not just about logos. Machine is actually learning a lot more things. We use 2 dimensions: the strength of the neurons and also the extent of the neurons. And there's a whole spectrum. Then I also talked about individual neurons, like generalists versus specialists, and explain a little bit about explainable AI. Thank you so much for your attention.
Wow. Thank you so much.